My name is Tisha Isler. I'm an academic coach at LJ Bell Elementary here in Richmond County. And my job today is to talk about the resources provided by North Carolina, Tools for North Carolina Teachers, and also the resources that have been uploaded on Canvas. So I'm going to start here with the Canvas documents. I have some good news. Cluster 6 and Cluster 7, Tools for North Carolina Teacher Lessons and Assessments and additional resources are now actually on Canvas. So you can get all your resources in one spot. So Cluster 6 and Cluster 7. Today we're going to focus on Cluster 6 and 7. There's so many wonderful resources that's provided. There are so many different resources provided on your Canvas under Cluster 6. I have actually provided some copies for you that's already printed, just so you'll have a printed version of some of these resources. But really, if you take your time when you're in PLC's planning and pick out what is best for your students, you're going to be surprised at the number of items that you can actually pick because there's so many good items. How often are you asking students to show their work in two different ways? How often are you challenging students to try a task before you jump in and help them? How often are you truly discussing what the students and their partners worked on without you? All these things are very important to the launch, explore, and discuss model that we've been working on in Richmond County this year. You need to make sure you're getting students started on a task and then having students work collaboratively with other people and then discuss the strategies they use. We want to empower students so they can continue to grow and truly learn mathematical concepts that's going to make them a better math student. One way to get students excited about doing a decimal notation unit or teaching decimals is to do a chant or a song. And there's actually a song on your webpage. Place value, decimals, tenths, hundredths. Place value, decimals, tenths, hundredths. Place value, decimals, tenths, hundredths. And my hands like this represent that decimal, and that normally looks like 8. Make sure students know that when they actually do this chant, that this decimal, this period, decimal, it represents and, the word and, A-N-D. But you also need to tell them that if they're looking at this decimal, this is the separator. And the way I look at my numbers, like to my right, will be my decimals. And then in front of that decimal to my left will be my whole numbers. But the way I'm doing tenths, hundredths, to them, the way they read it, it would be totally opposite if they're just looking at me instead of them actually doing it themselves. A way to launch, explore, and discuss is to just give students numbers. I mean, these are phone numbers, but you can use any numbers and tell them to make as many decimals as they possibly can, but they have to also convert that decimal into a fraction. And that'll just get students really focused on making different numbers using the materials you gave them. So if you look here, you make sure you tell them the decimal, and if there's a decimal, you know that the numbers to your right, they're smaller. So if you have a 2 here, 2 will represent 2 tenths. It's very important that you tell students to say the decimal correctly because that'll help them see the fraction. So we know that 2 tenths can be represented as a fraction or a decimal because it's the same. And then you also need to teach them that this 0 does not change the value of that 2 tenths. That's 20 hundredths, but 20 hundredths is equivalent to 2 tenths. So if you have 20 hundredths it will look like this as a decimal, but look like this as a fraction. And then you just continue, keep going, changing numbers, making sure you look at the decimal. You could do this with whole numbers, but it's a way to really get them thinking about what a decimal actually represents. And you need to make sure you're telling them that's 60 hundredths. You need to make sure you're telling them that anything after the decimal going to your right is actually getting smaller. The numbers are getting smaller, so they'll understand how to compare decimals later on. And then you also need to make sure they know that's parts of a whole. So just exploring these different numbers, and then talking to their neighbor about the numbers, the decimals that they're making, and also about the whole concept of how a decimal is made based on it being parts of a whole, and why our decimal is important, and just different concepts that can be discussed after they actually explore the numbers. If you notice on Canvas, you'll see information from the Tools for North Carolina Teacher Resources. We just want it all in one spot. And if you go to the anchor chart ideas, you could just preview it, but I actually want to open it. So I'm just clicking so I can open it. And I love these anchor chart ideas. And I love when teachers actually create anchor charts with their students. It is so beneficial for those students. But you know, Cluster 6 is all about NC4, NF6, and NC4, NF7. So if I click here, NC4, NF6, you notice it's talking all about decimals, all about decimals. It's showing you how you need to make sure students understand this is the place value chart for decimals, the main decimals that fourth graders need to know, the tenths and hundredths. And then it shows representation, a visual of tenths, and then a visual of hundredths. Another thing you could do is actually give students different visuals using the graph paper cutouts, and have them create their own decimals. And remember, have them say the decimal, because when they say the decimal, they're actually creating their fraction, because they're equivalent. 2/10. That's 2/10. But to make sure students understand the standard, they need to know that 2/10 is the same thing as 20 hundredths. This 2/10 is the same thing if it was 20 hundredths. Here, hundredths, 34 hundredths. So here, 34 hundredths. Now I can't say that 3/10 is the same thing as 34 hundredths, but if that 4 was a 0, it would be 30 hundredths is the same thing as 3/10. But you need to make sure you teach students that if they look here, they see 100, 100. They know that they got to make these denominators the same. They add a 0 here, that'll be 100, that's 100. They add that 0 here because whatever they do to the bottom, they have to do to the top. That'll be 30 plus 4, 34. But the more conversations they have about this, with students, with the teacher, with anybody that's willing to listen, the better their understanding of tenths and hundredths and how they are related to a whole number. Remember, a decimal, anything past that decimal is parts of a whole. So it's part of a whole, and it's different parts of a whole. 1, if that number was a 1 after that decimal, that would be represent 1/10. If I go all the way to 9, I have 9/10. But then as soon as I hit, I can't have 10/10 because 10/10 represents what? 1 whole. Any number over itself represents a whole. So students need to know that 5 over 5 is 1 whole. So 6 over 6 is 1 whole. Just all those different concepts. Students need to really talk about these concepts and have a deep understanding of these concepts to be better mathematicians. Another anchor chart included in your resources for cluster 6 and cluster 7. And if you notice, are they equal? This is a part of cluster 7 for NF7. And that's comparing two decimals to hundreds by reasoning. And if you notice here, are they equal? You can look at this and tell the visual that is not equal. It's actually not equal. That's just two little places, two little pieces of 1/10. This is 2/10. So it's important for students to realize that. And looking at this one, this is 7/10, and that's 7/100. And students should look at this and be able to tell that this is closer to the whole. And if they can't tell initially, the more practice and the more discussing, they'll start seeing these numbers clearly. Here, looking at these rulers, you could tell that 5/10 is actually bigger than that 5/100 because it's small. The 5/100 is so much smaller. Same thing here. 7/100 is so much smaller than 7/10. And 2/10 over here is so much bigger than 2/100. So they are not equal. So if I continue to look at these anchor charts, is a comparing decimals anchor chart. And I really like this comparing decimals anchor chart just because it's straight to the point. If you notice, we have 9/10 is greater than 32/100. 9/10 greater than 32/100. You can compare that by adding that 0, so it'll be the same amount of numbers after the decimal. So that's 90/100 is greater than 32/100. And looking at this, it makes even more sense why this is greater. But we have to remember to teach kids when they see 9/10, they should also see in their mind 90/100. And if you look down at this last visual, it shows you very clearly how 9/10, this is 9/10. So one more colored in would make that what? A whole. So that shows you that 9/10 is close to a whole. But if you look here, 90/100 is close to a whole. They're actually equal. If you count the pieces, that's the difference. That one piece is broken up to smaller pieces. That's your 10. 10 smaller pieces in one 10. 10 smaller pieces in the next 10. And further up. And that's why 9/10 is equivalent to 90/100. Students need to understand that. Students need to see that. Students need to explore it. In cluster 7 of Canvas, there's some really, really good videos that you need to show your students. They came from YouTube, but they're on your Canvas because they're so good. This is all about mixed numbers, and it is really a good video. And this could be a part of your
Hi, I'm Rob. Welcome to Math Antics. In this lesson, we're going to learn about mixed numbers and how they relate to improper fractions. Mixed numbers. I love mixed numbers. So full of protein and vitamins. You want some? Those are mixed nuts, and no thanks. I'm trying to explain mixed numbers. Oh, mixed numbers. You mean like when I get a whole bunch of numbers and put them in a bag and shake it up, pull out one to see who wins? You want to play? That's a raffle, and that's not what mathematicians mean when they say mixed numbers. Well, you sure are hard to please today. As I was saying, we're going to learn how mixed numbers relate to improper fractions. But first, we need to make sure that you understand what an improper fraction really is. To do that, let's start with a short number line that counts whole numbers from 0 to 3. And let's subdivide the spaces in between each whole number into 4 equal parts, or fourths. So a block this size represents the amount 1, because it covers the distance from 0 to 1. While a block this size represents the fractional amount 1/4, because it only covers the distance from 0 to the first subdivision that we made, which is 1 out of 4, or 1.
This is subtracting mixed numbers.
Hi, I'm Rob. Welcome to Math Antics. In our previous lesson, we learned how to add mixed numbers. And in this lesson, we're going to learn how to subtract them. Subtraction is always a little trickier than it.
NC4, NF3. If you notice, there are certain denominators that will be used. 2, 3, 4, 5, 6, 8, 10, 12. And also 100. So that means you really need to expose students to these denominators as much as possible. But if you look down and truly look at this anchor chart, it is very helpful to show students all these different models. This first model, the number line, I think is a great visual, especially for students who love to use the number line. If you look here, it's showing in red the whole numbers, how they hop using the whole numbers. And if you notice, they're at 3, but then when they do the fractions, and remember fractions are part of a whole, they actually put the little tally marks in between, because remember, you're making out like 1, 2, 3, 4. It would be 5 would make it a whole. So if you look here, they put 4/5 to be here, and then the 2/5, by them that being one of them, that makes that a whole, and then one left, that means the answer is 4 1/5. Then if you look over here, this model is one whole, and then it's showing you 1 and 2 is 3. And then after they do that, they actually break up the fractions 4/5 plus 2/5. And at 4/5, and then they add that 2, and they realize that that's one whole, and then it's 1/5 left. Students drawing that visual and seeing that visual often, they're gonna really understand the concept of adding mixed numbers, especially when it's like denominators. So if you look here, use equivalent fractions, and remember what we talked about previously in cluster 6. If you look here, 5/5, that equals one whole. So they use 5/5 because the denominator is 5. So they're using equivalent fractions, 4/5 plus 10/5 plus 2/5. And why do you think they put 10/5? Because what? 5/5 plus 5/5 is 10/5, and that's a 2. So then you add it all together, and you'll get 21/5, 21/5. So then if you divide 21 into 5, you get 4 1/5. It's another way to do it. So many different ways. Students just need to be exposed to this variety of ways. Here, 1 4/5 plus 2 2/5. 2 plus 1 is 3, and then you go over here, you get 6/5. If you notice, that's an improper fraction, so you want to make it a mixed number. 6 divided by 5, you get 1 1/5. Then you got to add that 1 1/5 to 3. You get 4 1/5. This is just a great anchor chart. And multiplying a fraction by a whole number, that's NF4. And if you notice, 3/8 times 5 equals 15/8. That's the improper fraction. And to change it to a mixed number, it'd be 1 7/8. But if you notice that 5, anytime you have a whole number, if you go ahead and put the divided by 1, which 5 over 1 equals 5. Then you know 5 times 3 is 15. 8 times 1 is 8. 15 eighths. Repeated addition. They showing you another way. Since 3 eighths times 5. 3 8 plus 3 8 plus 3 8 plus 3 8, 3 8. That's 5 3 eighths. Equals what? 15 eighths. If you add it, that's 1 7 eighths. And then it's also showing you the visual models of 3 eighths. And if you notice, it's 1, 2, 3, 4, 5 because you're multiplying it by 5. But then you have 8 represent the denominator, and then it's 3, the numerator, 3 eighths, 3 eighths, 3 eighths, 3 eighths, 3 eighths. And that equals 15 eighths, or 1 over 7 eighths. And then that's what I told you up on the top, 3 eighths times 5 over 1. 15 eighths equals 1 7 eighths. So I still, in my mind, I always, when I see this, I see that invisible division over 1. So that's just what I see.